This lesson is on Chapter 5, Section 1, which is rational numbers. The first thing we need to do is go over a few vocabulary words. So, the first is, what is a rational number? A rational number is a number that can be written as the quotient of two integers, meaning whole numbers, no decimals. So, for example, if you had 9, to write it as it's a rational number if it can be written as a quotient. So 9 divided by 1, that's a rational number. Or if you had 3 and 5/12, you could write that as an improper fraction by saying 3 times 12, which is 36, plus 5. We could rewrite this as 41 over 12, so that's also a rational number. A terminating decimal is a decimal that has a final digit. So what they mean by this is, let me give you an example. So let me think of for a second. So if you had a division problem, you're doing long division, and it came out that you had a remainder of 0, that would be an example of a terminating decimal because there isn't a continuous remainder. So it doesn't keep going. Alternatively, you could have a repeating decimal, so a decimal that has one or more digits that repeat without end. So it never terminates. You always have a remainder and it keeps going and going and repeating. And we'll do better examples of this in a few minutes. So here's some of the examples I gave you on the previous page. If you had to write each of these, A, B, and C, as a quotient of two integers, the first, 9, would be 9 over 1. B, we would said 41 over 12 because we made it into an improper fraction. And C it's a little tricky because there's a negative sign, but all you need to do is think of it as a positive and then remember to put the negative at the end. So make it into an improper fraction and then assign the negative to either the numerator or the denominator. It doesn't matter which, but make sure it's only one. So try these two on your own to write them as rational numbers by using only a quotient of two integers. Example 2. So this gets into writing fractions as decimals. So for example, 7 over 8, we can do a long division problem. So we can say 8 goes into 7 how many times? So remember, what's on the top goes on the inside here, and what's on the bottom goes on the outside. So then we can then start doing our long division, which you should remember how to do. Because it came to a 0, we know this is a terminating decimal. It ends here, so 7/8 is equal to 0.875. Nothing's repeating. And for 4/11, here we do end up getting a repeating. So if you see here, as I did this, 11 goes into 40 33 times, and we're left a remainder of 70. Then you get 66, left a remainder of 40, 33, 70. You're going to start seeing this pattern of 36, 36, 36. It'll go on forever. So we write 4 over 11 equals 0.36. Since the 3 and the 6 are both repeating, a line goes above it. So this is a repeating decimal, where this is a terminating decimal. So give those a try. You can use your calculator. You don't have to do the long division, but it's good practice if you haven't done it in a while. So try number 3 and 4 by pressing pause now. Example 3. So in this case, write terminating decimals as fractions. So if we had 0.9, we can write it's the tenths place, so the denominator of 10. Since this is the tenths, here we go out to hundredths, so we put it over 100. I hope that makes sense. So here, since we're only one decimal place, 9 divided by 10, because they're in the tenths place. In this case, we have 0.31. You go out to the hundredths place, so we put it over 100. So try that with the following two below. And the last example is probably the most challenging. So if you didn't have a calculator, how can we write a repeating decimal as a fraction? So let's try the repeating decimal of 0.45, which is repeating. So the first thing we're going to do is let x equal, so we're setting this as our equation, x is equal to 0.45 repeating. Now step 1, because 0.45 has 2 repeating digits, we're going to multiply each side by 10 to the squared, or 100. So we're taking this equation and we're going to multiply both sides by 100. So we are left with 100x equals 45.45 with the 45 decimal repeating. Step 2, we're going to subtract x from 100x. So we go back to this original equation here and we're going to subtract it. So the minus x goes on the side with 100x, and the minus 0.45 repeating goes on the other side. So you're left with 99x equals just 45. We canceled out this repeating. And then you can divide both sides by 99, so you get x is equal to 45 over 99, and then you see if it can be simplified. In this case, we can simplify it by dividing by 9 and get 5/11. So 0.45 repeating is equivalent to 5/11. So this is a little tricky. The key things to remember is if it has 2 repeating digits, we multiply by 100. If it was 0.3 repeating, we would just multiply each side by 10. If it had 3 repeating digits, then you do 100 or 1,000. And then you always subtract this original equation that we wrote here. So first you multiply it by whatever factor, 100 or 10, depending on the number of repeating decimals. Then you go back and subtract that original equation. So I want you to try one on your own. So take your time and try 0.32 with 32 repeating and bring it with you to class tomorrow. This is really good practice. And that's all for the lesson today.